or decrease by, and then calculate that as a percentage. That's what we're doing today. So a percent change can either be an increase or a decrease. And you can tell by looking at the numbers, did it start lower and go up, or did it start higher and go down? That's how you can tell if it's an increase or decrease. If you use the equation, your part is going to be replaced by how much the thing changed by. Your percent will still be percent. Your whole is going to be whatever the starting amount was before there was change. Now, if you use the proportion, you'll set it up where you have percent over 100 still. That's the same. And then we just have to figure out how much it changes by and put that over the original or the starting amount. And maybe we want to write up here, original can also be thought of as the starting amount. All right, so that's how we calculate percent change. Let's actually do some examples and make sure it makes sense to you. So last year, a website had 40,000 visitors, and this year it had 37,000 visitors. What is the percent change in the number of visitors to the website from last year to this year? All right, so I'm going to show it both the equation way and the proportion way. You can choose to just write down the way that you like to do it. That's fine with me. Just make sure that you are being quiet when I'm explaining the other way so that kids who use the different method can still figure out what they're doing. Okay, so last year the website had 40,000 visitors. This year it was 37,000. I can already tell that's a decrease because it went down. So to calculate how much it went down by, what percent it went down by, we have to figure out how much did the website traffic change by. And you do that by subtracting what was it at to start, 40,000, and then it went down to 37,000. How much did it change by? 3,000. So the amount of change is 3,000. Now we need to figure out what that is as a percentage. So if we want to fill out the equation, the change is the part. So we'd have 3,000. And that equals our percent as a decimal times our original amount, which was the 40,000. It started at 40,000 first, and then it went down to 37,000. Okay, so then x times 40,000 equals 3,000. So if we want to figure out x, we have to go backwards and divide by 40,000. And x would equal 0.075. Remember, that's as a decimal when it's in the equation. So to get that as a percent, we multiply it by 100 or move the decimal point 2 spaces, and we get 7.5. All right, let's solve it the proportion way. So we'd set it up like this. Our change is 3,000. We already calculated that out. Our whole or original, starting, total, those all mean the same thing. That is our whole, and we have to figure out what percent that is out of 100. Then remember, we use cross products, so we multiply the two corners where we know the numbers. So it'd be 3,000 times 100, and then we divide it by the number with x, 40,000, and we would get 7.5. So either way, you can see we would get a 7.5% decrease. And I want you to label it 7.5% decrease. Whether it's an increase or a decrease, you should label what it is. All right, we have one more example, and then I do have something I want you to write in things to remember as well. Pause if you need to get this down. The left side is the equation way, the right side is the proportion way. All right, next example. Now, the other thing you can calculate using this equation is percent error. How much is something off from what it should be? So this one, let's just read through it and see how that applies. So Sean estimated that the attendance at a college lacrosse game was 3,000. The actual attendance was 3,296. What is the percent error of Sean's estimate? What percent was he off by? Round to the nearest whole percent. Okay, so Sean estimated it was 3,000. The actual was 3,296. What is his error? And then round to the nearest whole percent. Okay, so we can solve it the equation way first again. So we have error is our part and actual is our whole. So let's figure out how much he was off by. What was his error? 3,296. I'm gonna have to use my finger. My stylus is dying. 3,296 minus 3,000. So he was off by 296 people on his estimate. So his error was 296. And that equals the percent error, which is what we don't know. They want us to find his percent error. The actual amount at the game was 3,296. So if we want to figure out that missing x value, we would divide. It's x times 3,296, so we have to divide by 3,296. And we get x equals 0.0898, and it kind of keeps going. That's the decimal. We need to multiply it by 100. And if we multiply it by 100, you'll see it's 8.98 blah, 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 which rounds to 9%. So he was off by 9% when he made his estimate for the game. Okay, and then just to show you the proportion way quick, we figured out the amount he was off by was 296. So his error is 296. That's the part. The whole is the actual amount that we're at the game, 3,296. And we're trying to find the part over 100. You should be pretty good at cross products now. So you would do 296 times 100 divided by 3,296. And x would equal 8.98 other numbers. If you round that to the nearest percent, it'd be 9%. So it's 9% error. Okay, I hope that example helps. The error can be a little bit tricky, so make sure you write this down in your notes so you remember how to figure out what part goes where. Finally, let's fill in our things to remember box. I'm just going to make a new slide right here for us. And in your things to remember box, you can put anything else you want, obviously, but to find the change or the error, you need to subtract. So find the change error by subtracting the new minus the original, or the estimate minus the actual amount. So the new minus original is for percent change, and then percent error is estimate minus actual. Write that in your notes. Pause if you need to. I hope this helps, and have a great day.